we've so far discussed the fact that you should always take the greatest common factor out first. Our next step was to count the number of terms, and we've already dealt with a situation where there are 4 terms in the binomial and you'll factor it by grouping. Now what I'd like to concentrate on is a trinomial, a situation where a polynomial has 3 terms. And specifically, I'd like to take you back a chapter and have you look at the method of foiling and notice how the product of 2 binomials, such as these 2, results in a trinomial. So let's FOIL. I have x times x is x squared, and x times 4 is 4x, and 3 times x is 3x, and 3 times 4 is 12. And when I combine my like terms, the 2 terms in the middle, the inner and the outer terms, I'll have 4x plus 3x is 7x, and I'll have my last constant term of 12. Here's a trinomial. That's where we're going to focus now. We're going to look at factoring polynomials that have 3 terms, and our goal is to take this trinomial and to factor it back into the product of 2 binomials. We won't go there quite yet. Let's just look at one more situation. I'd like you to compare these 2. Let's multiply or FOIL these 2 binomials. So x times x is x squared. Then I have a minus 2x and a positive 7x and a minus 14. And when I collect my inner and outer terms, the minus 2x and a positive 7x gives me a plus 5x minus 14. What I'd like you to notice is the original problems. Would you please notice that the factors of this trinomial, we are going to factor this into x plus 3 times x plus 4, what we began with. Would you please notice that these 2 numbers right here, the 3 and the 4, multiply together to be the last term, and the 3 and the 4 add together to be the coefficient of the middle term, the 7. Just like this one, we are going to be factoring this trinomial into x plus 7 times x minus 2, and I'd just like you to notice that the 2 constants, 2 times a negative 2, their product is a negative 14, and their sum, a positive 2 and a positive 7 and a negative 2, adds to be 5. That's because of this process of FOILing where the inner and the outer terms add together to be the middle terms. Again, right here, that 4 and that 3 add to be that 7x. Let's go on to factors. There are 2 situations when it comes to factoring trinomials. Trinomials are typically expressed theoretically, if you would, like this, where we have our first term that has a coefficient a, x squared, plus the second term, a coefficient of b, plus a constant. The first situation that we're going to look at is one where the coefficient of the first term, a, is equal to 1. That's a little bit easier to factor than this situation where the coefficient in front of the x squared term does not equal 1. For example, looking at this situation in the next couple of examples, if I have x squared plus 9x plus 20, and I want to factor that, I'm going to factor that into the product of 2 binomials. And in the front of each of those binomials, I need a term, and those terms, when multiplied together, have to equal the first term in the trinomial. So in this situation where the coefficient is a 1, I'm always going to have an x in the front of these because x times x is x squared. The next thing you're looking for is a term to put in the back end of each of these binomials. Their product has to be this 20, and their sum has to be the 9. Most of us can come up with that fairly quickly if these numbers are not too large. In this case, 2 numbers whose product is 20 are 5 and 4 because their sum is 9. While options like 2 and 10 are possibilities for products, or 1 and 20 are possibilities, they don't add to be 9. This is the factored form of this trinomial. Continuing this process of factoring trinomials, where the coefficient in front of the first term is a 1, I'm going to look to factor this trinomial into the product of 2 binomials, where the first term must be an h because the product of those 2 will give us h squared. I'm looking for 2 numbers whose product is 18 and sum is 11. If you don't see that fairly quickly, you might just create a table for yourself and write down the fact that you're looking for 2 numbers whose product is 18, whose sum is 11, and to keep that process organized, start with the number 1 and decide if each consecutive whole number goes in, and 2 does go into 18, and think of 2 times 9. and 3 goes into 18, 3 times 6, and continue that process until you've run out of factors. Of course, there is the possibility of using negative numbers for both of these because their product would be 18, but I want these numbers to add up to be a positive 11. When I go over to check these, 1 plus 18 equals 19. That doesn't work for this situation. I check this one, 2 plus 9. It does equal 11. Those are the two numbers I'm looking to put in here. I want one of these to be a 2, one of these to be a 9. I could write it like this, or I could have put the 9 first in the first binomial and the 2 second. It doesn't matter because multiplication is a commutative process. I've factored this trinomial. Either situation represents, there are two ways to represent the solution to that problem. If a polynomial is not arranged correctly in descending order of the exponent, you should always do that first. In this problem, we should take the k squared term and put it out in front, and then put the 10k and finally the 24. Now it's in a position to factor this fairly readily. Remember again to open up two sets of parentheses. In this case, I'll put a k in the front of each. I now need two numbers whose product is 24 to go in here, and I'm going to write that here just to keep reminding you that. Product is 24, and the sum of those two numbers has to be 10. So again, while 1 times 24 is an option, and 2 times 12 is an option, and 3 times 8 is an option, finally 4 times 6 is the option that will work because those two numbers, product is 24, and they add up to be 10. Again, please don't forget that you could have put the 6 in first and the 4 in second. That we factored so far have had plus signs in front of the second and the third term. I'm going to, for the next two examples, illustrate what would happen if there was a minus sign in front of the second term and a plus sign in front of the third term. While you don't have to memorize the situation, you have to recognize that it's what's going to be true about this situation. So, like the other problems, I'm going to factor this into the product of two binomials, and I'm going to put an x in the front of each because their product has to be the first term. I'm now looking for two numbers whose product here is going to be a positive 12, yet the sum of those numbers has to be a negative 7. Again, product is 12. Yet these numbers have to add up to be a negative 7. The only way for that to happen is for the two numbers that we're going to work with to both be negative. So if I were to create a list of values, I've got to try a negative 1 times a negative 12 and see if it adds up to be a negative 7. Or I've got to try a negative 2 times a negative 6 and see if they add up to be a negative 7. Or I've got to try a negative 3 times a negative 4, and those are the two values that do add up to be a negative 7. So what you need to recognize is that in this situation where I want two numbers whose product is some positive value, but their sum adds to be a negative number, I have to have two minus signs. In this case, a minus 3 and a minus 4. Let's try another one of those. I want to factor this trinomial into the product of two binomials. Again, an x goes in front of each of those parentheses. I need two numbers whose product is a positive 15. But they should add to be a negative 8. So I'll immediately think about the fact that I need to put minus signs in those binomials. And again, two numbers whose product is 15, 5 times 3. I'm wanting them to add to be a negative 8, so it'll be a minus 5 times a minus 3. Again, I could write that as x minus 5 times x minus 3, or I could write that as x minus 3 times x minus 5. And when you take the test online, it will recognize both of those answers. Last situation. A trinomial with a 1 in front of the x squared term, and I want to factor it into the product of two binomials. But now we're going to vary this sign, but maintain that this sign will always be a minus sign. With that, I'm going to factor this into the product of two binomials, again, and an x in the front of each. I now need two numbers whose product is a negative 45. You don't need to memorize anything. You just need to know that if two numbers' product is a negative 45, one has to be positive, one has to be negative. I don't care which place you put it in, you just got to have one of each. And if the two numbers' product has to be a negative 45, and in this case has to add up to be a negative 4, and I were to start to list some numbers, just check out your possibilities. You could use a negative 1 and a positive 45. Or you could use a positive 1 and a negative 45. Those two pairs don't come anywhere close to adding to be a negative 4. 2 doesn't divide into 45, but a 3 does. So I might go with a negative 3 times 15, or I might go with a positive 3 times a negative 15. Again, those aren't going to add to be a negative 4, so my next factor I might look at are 5s. I could use a negative 5 times a positive 9, or a positive 5 times a negative 9. And I look at those pairings, and I look at the set that will add to be a negative 4, and it's this set right here. I needed the one that had the higher absolute value, if you will, to have the minus sign in order for it to add to be a minus 4. So I need to put the 9 in here, the 5 in here. If I FOILed that, it would come back to be this trinomial. Again, remember, you don't have to write it like this. You could have written it as x minus 9 times x plus 5. Here's our solution. In this problem, the minus sign still exists in front of the third term, but I've got a plus sign in front of the second term. Similar situation. I'm going to factor it into the product of two binomials. Because I want the numbers that I place here to have a product of a negative 18, I'm going to put a plus sign in one and a minus sign in the other. And I need two numbers whose product, I'm going to abbreviate this, is a negative 18, and whose sum is a positive 3. So while I have to pick the possibilities or think about the possibilities of a negative 1 times 18 and maybe 1 times a negative 18, please notice now, to try to shorten your work, that of these two numbers, the higher one, before you put signs on it, should be positive, and the smaller one should be negative in order for their sum to be a positive 3. So I won't bother with writing 1 times a negative 18. My next option might be a negative 2 times 9, but those don't add. A negative 2 and 9 does not add to be 3, so I might try now a negative 3 times 6. And it does happen that a negative 3 and a positive 6 does add to be 3. So I'll put my 3 right here, my 6 right here. I've satisfied the fact that the product is a negative 18 and the sum is a positive 3. I'm done. My broken record comes on. The first thing we talked about when it comes to factoring is to take the greatest common factor out first. This problem, while it is a trinomial, has a greatest common factor that can be taken out of every term. The numerical factor that can be taken out is a 7. It divides evenly into every one of those. So take that out, and it happens that every one of these terms has the variable x in it. You've got to take out x to the smallest power within all of those terms. So in this case, take out x to the 7th. And what you're left with, when you just factor that greatest common factor out, here you'll need an x squared, because this 7x to the 7th times x to the 2nd will give you 7x to the 9th. Remember, you're adding exponents when you multiply. You'll need a minus 4x here for this product right here to be the minus 28, x to the 8th. And finally, you're going to need a minus 5. So that's always your first step. Now, we're not done factoring this yet. We've got a trinomial here that we need to try to factor into the product of two binomials. So I will put an x in the front of each of these. And because I have a minus sign right here, I'm going to recognize that I need a plus sign in one, a minus sign in the other for the product to be a minus 5. And I need these two numbers that I choose, and the only factors of 5 are 5 and 1. I need them to add to be a negative 4. So I better make that a minus 5 and a positive 1 for those to add to be a negative 4. Don't forget to bring down that greatest common factor, 7x to the 7th. This is the factored form of the original problem. I had to take the greatest common factor out first. Don't try to skip steps. Then go with factoring this trinomial into the product of two binomials.